Welcome, geometers. We are going to talk about transversals and angle relationships. But before I do that, I want to talk about something that you already know something about, which are parallel lines. And as you already know, parallel lines are coplanar lines that never meet. And we want to distinguish that from non-coplanar lines that never meet. So let's bring in this picture here about, here's a couple lines. They sure look parallel, but you would not say that they're parallel unless I put some kind of symbol on there like this, some notation that tells you that these are parallel lines. So now I could say A is parallel to B, and we already know how to write that. A is parallel to B, and remember there's different ways of naming those lines. If I had points on the lines, I could say line PQ is parallel to RS or something like that, but I already talked about that, so we won't go into a lot of detail. But I want to distinguish that between why do you have to say coplanar lines that are never meet? Well, these lines A and B are on the plane in which I'm drawing, and that's what the intention of the picture is. And skew lines, this idea of non-coplanar lines, non-coplanar means not on the same plane. Here's a picture down here of what's supposed to be a box, and I've got two planes shaded red and blue, and their intersection is a line. This green line that I'm putting in here is the intersection of the red plane that makes up one side of this box, one face of the box, and the blue one that's in the back. They intersect in a line. It's green, and it goes on forever, as those planes would go on forever. And then down here, the bottom of this box is, I've put another line, this blue line, and those are non-coplanar because one is in the plane that's closest to you that you can see through, and you can see back to the back of the box, which with the red and the blue, and they intersect back down. Now, if this is hard for you to visualize, one good thing to do is just look around the room that you're in. And if you look at the plane of the floor and the plane of one of the walls coming down, they intersect in a line. And then if you look at the ceiling and a different wall and where they intersect, that's a line. And those will never intersect. And hopefully you can see that in the room that you're in. It's always a good idea, especially with these three-dimensional pictures. I want to talk about one more preliminary thing here. Here's an angle. We've seen lots of angles. And I think you already know this too, or have a good sense of it. Here we'll all use smiley faces to color this. This part with all the smiley faces in it, this is called the interior of this angle. Of course, that would all continue out as far as I wanted to take it. If I wanted to extend the rays of the angle further out, I could also extend the smiley faces out there further. That's called the interior of the angle. And this part out here that I will fill with blue stars, that's the exterior of the angle. Okay, so an angle has an interior and exterior. We might want to use that information here as we define some more things. So moving on, here's a picture, and I've got it labeled. I got a blue line on there, and I got two red lines, A and B. And the first thing we want to talk about is this idea of a transversal. Here's the definition of transversal: a line, like T, that intersects two or more lines at distinct points. Okay, well, line T intersects line A at, I'm not going to name it, but I'm going to put a big purple blob there at that point, and line T intersects B at this purple blobby point right there. Those are distinct points. Now, three lines could all intersect in the same point, and that would not, then there wouldn't be a transversal. But this picture, the blue line, intersects both A and B at distinct points. Now that forms a bunch of angles. When you have a transversal in two lines, you always get these 8 angles formed, which I have named by numbering them. The relationship between these angles all have special names, which you need to know and know well. So let's start out by, and these are not so hard because most of these definitions or these names are quite descriptive as to what they are. So for example, alternate exterior or alternate interior angles we're going to start with. Two angles that are on different sides of the transversal. They're called alternate or opposite. They are on alternating sides of the transversal, on opposite sides of the transversal, and whose interiors are between the intersected lines, or at least the beginning of their interiors are between the intersected lines. Okay, in this picture, some good examples of that would be angle 3. I don't like drawing with that. Let me find another pen to draw with. Angle 3 and angle 5. Those are alternate interior angles. See the interior here. I got some kind of magic pen or something like that here. This is the interior of 3, and this is the interior of 5, and they're on alternate sides. And oh good, it fades away. I was hoping that would happen. And those are the two angles that I was talking about. Well, what's another pair of alternate interior angles? You probably guessed it already. Angle 4. Hey, wouldn't those be alternate interior? Because they're on opposite sides of T, and they're in the interior. They're between the lines. And what about 3 and 4? Those are on alternate sides. And they're both on the interior. But we already have a name for 3 and 4. Those are called a linear pair. And 5 and 6 are a linear pair. And they also, 4 and 3, don't involve both lines. So all these names that we're talking about have to involve angles formed by both of the lines that the transversal is crossing. That's really important to remember. I don't want 3 and 4. I don't want 5 and 6 or 5 and 8. Those are all, we have names for that. We don't want 2 and 4. 2 and 4 are, we already have a name for that. Those are vertical angles. 1 and 3 vertical angles. So we want to involve both lines and the transversal. Otherwise, we already have a different name for those things. So alternate exterior angles or alternate or opposite exterior angles. I don't really care what name you use as long as you can describe them well. Two angles that are on different sides of the transversal again and whose interiors are outside the intersected lines. For example, angle 1 and angle 7. They are alternate exterior angles. And what else do we have? Angle 2 and angle 8. So these are nice descriptive names. Alternate means on either side of the transversal. Interior means between the lines. Exterior means outside the lines. Okay, moving on. Same side, or sometimes called consecutive. I like same side because it's descriptive. A lot of times you don't understand what consecutive means. But same side, on the same side of the transversal, and that's exactly what it means. Two angles that are on the same side of the transversal and whose interiors are inside the intersected lines. So, for example, 4 and 5, angle 4 and 5. And let's use this magic pen. Let me show you something with this magic pen. If I draw this in, draw along this thing, they kind of make a C or an upside down C or something like that. Those are alternate, or those are same side interior angles. Over here, these two, 3 and 6, would be alternate interior angles. Okay, let's write that down. Angles 4 and 5. And angles 3 and 6. A couple more here. Same side exterior angles. Again, the name tells you what they are. Angles 1 and 8 are that kind of pair. And what else do we have? Angles 2 and angle 7. Same side of the transversal, 1 and 8, and on the exterior, 2 and 7, same side to the right and on the exterior. This last one called corresponding angles. Where did it go? There it is. Corresponding angles. Give me some space here. Two angles that are in the same relative position with respect to the transversal and the lines it intersects. Here's what that means. What do I mean by in the same relative position with respect to the transversal on the lines? Okay, angle 3 is below A. It's on the interior, but it's below A and to the right of transversal T. Angle 7 is below B and to the right of the transversal. That's what I mean by in the same relative position. They're both, if you're using directions, they're both in the southeast corner. Okay, same relative position. So 3 and 7 would be an example of corresponding angles. 3 and angle 7. What's another pair of corresponding angles? 1, and would it be its corresponding angle? 1 and 5, because they're both above their respective lines and to the left of the transversal. Angle 1 and angle 5. There's actually 4 pairs of corresponding angles in this picture. 2 and 6. And one more. What did I get here? 4 and 8. Angle 4 and angle 8. Okay, so they're in the corresponding position. I have one more thing I want to show you, and that is a more complicated picture. Make sure you get all these definitions down. Pause the vodcast if you need to get them written down before moving on here. Here's a more complicated looking picture. Look at this thing. I've got line A. I've got line B. That's the black one. I've got line C. It's the red one. I've got line D. That's the green one. And there's 16 angles formed. And not only that, but line A is a transversal for B and C. Line C is a transversal for D and A. Line B is a transversal for A and D, and so forth. Each line could be a transversal because each line crosses 2 other lines in 2 distinct points. So when you're naming these angles, make sure you clearly identify what the transversal is. So for transversal C, let's say, what is transversal C? Well, that crosses A and D. So the angles that I'm looking at are, up here and up and wow, that's cool. Don't want that. This one, oh, it's still doing that. Okay. Anyway, you see what angles I'm talking about. So if I wanted to talk about alternate interior angles formed with transversal C, alternate interior angles, I might say angle 1 and angle 14. Okay, but what is angle 1, if I'm using D as the transversal? If I'm using D as the transversal, then angle 1 is exterior angle now, right? And D is a transversal, 1 is on the outside of C. And what would be the relationship between angle 1 and angle 8, let's say? Well, let's see. Angle 1 is on the kind of downward side of D, and that's on the outside, and angle 8 is on the downward side of D, below it, and it is to the left or sort of above B. So those are corresponding angles, right? Corresponding angles, because they're in the same relative position to transversal and their respective lines. So we'll look at lots of complicated drawings like this, and even some that get more complicated. And also, we want to talk about some special things that happen with these pairs of angles that we've just talked about when lines are parallel, but that's a different day, a different time. Okay, so hopefully you've got some good notes on this, and you can rewind this, watch it over again. Make sure you've got good pictures in your notes.